Okay, WPP number 5, and it reads, D. Rose wants to donate an indoor basketball court to Batman because he wants to try out for the Superhero All-Star Game. He invests $5,000 in a 24-month CD with 7% interest. Part A, how much money will he have at the end of the term if it is compounded daily, weekly, monthly, quarterly, semi-annually, and annually? Okay, so first of all, we need the equation for this, and that is A is equal to P 1 plus R over N to the N T. And then we could break it down by labeling each part A, P, R, N, T. P is going to be 5,000 or 0.07. It is written as a decimal, and time is 2. And we won't have anything for A or N. And then we just simply plug this in, and A is equal to 5,000 parentheses 1 over 0.07 over N times 2. And now if we want to find it daily, we use 365, 52, 12, 4, 2, and 1. And that's going to be for each. That includes daily, weekly, monthly, quarterly, semi-annually, and annually. To find these, we plug in this equation that we have right here into our calculator. I already have it plugged in right here, and we just graph it, we trace, and then we just select the X value. And then for 365, it's going to be 5,751 and 29 cents. For 52, it's going to be 5,750 and 83 cents. For 12, it's going to be 5,749 and 3 cents. For 4, it's going to be 5,744 and 40 cents. 44. For 2, it's going to be 5,737 and 61 cents. And for 1, it's going to be 5,724 and 50 cents. And that's part A. And now part B is how much will D Rose have at the end of the term if it is compounded continuously. And if it is compounded continuously, we use the equation A equals PERT, P-E to the R-T. And our P remains the same as the previous question, so it's 5,000 to the E, or not to E, sorry, 5,000 E to 0.07, which is our rate, times our time, which is 2. And we just simply plug this in to our calculator. 5,000 E to the 0.07 times 2, and that gives us as A is equal to $5,751.37. And that's part B. And now part C. Oh, that's part D. Part C. If he needs $12,000 and has $5,000 in the account, what interest rate does he need? And we are going to use PERT again. A equals PERT. And it's different this time because we are going to have an A value, which is 12,000. So 12,000 is equal to 5,000 E, and rate, we're finding the rate. Oh, and this is 2 years. I forgot to add that in. That's 2 years. For 2 years, as 24 months, 2 years. And we just simply want to get R by itself, so 5,000 divided by 5,000, that cancels. And then 12,000 divided by 5,000 is equal to 2.4 e to the r times 2. And we want to take the natural log of both sides. That cancels because that's just equal to 1. Natural log. And then r to its natural log, 2.4 is equal to r2. And now we just divide by 2. And when we take the natural log of 2.4 and divide by 2, we get r is equal to 0.4377. And we bring the decimal back 2 places, which is 43%, 43.77%, and that is not gonna happen. That is just not gonna happen. And now finally part D. How long must you have the money before reaching 12,000 with an interest rate of 5%? We use PERT again, so 12,000 is equal to 5,000 and E, and now we're gonna have 0.05 for our rate, and now we're finding the time. And then we simply use the same process as we used to find the rate. It's pretty much similar, just divided by 5,000 divided by 5,000. We know that gives us 2.4, and then we take the natural log of both sides, which cancels with e, and now it can be natural log of 2.4 is equal to 0.05 t. And now when we do that, so natural log of 2.4 divided by 0.05 gives us 17.5. So t is equal to 17.50, but we're not done there yet. We know it's 17 years, but we need to know the amount of months. And to do that, we do 50 over 100 is equal to x over 12. We set up this proportion. And 50 times 12 is equal to 600 divided by 100. That gives us x is equal to 6. And that means that it's going to take 17 years and 6 months for D Rose to reach $12,000 with an interest rate of 5%. And that is WPP number 5.